This video is about function notation. We're going to learn how to evaluate a function that's written in function notation. So first we need to understand what is a function. A function is a relationship between two quantities in which one quantity is associated with a unique value of another quantity. What this means is when I put something into a function, I know what value we'll be getting out of the function. So let's take an example and look at two different vending machines to figure out which one is a function. So in the first vending machine called refreshments, each button is associated with a different drink. So if I hit A, I'm going to get orange juice, B, apple juice, C and D are both skim milk, E is chocolate milk, and F is water. I know when I hit a button, what drink is going to come out. In the cold drinks machine, if I hit A, I'm going to get orange juice. If I hit B, I'm going to get apple juice or skim milk. In C, I'm going to get skim milk. D, I'm going to get chocolate milk. E and F, I'm going to get water. So as you see, there's two drinks associated with button B. So I don't know which one I'm going to get when I hit that button. So which one represents a vending machine? Is a function. The refreshments is a function. Because each input, which in this case is a button, is associated with one output, which in this case is a drink choice. So, which vending machine does not represent a function? Cold drinks is not a function because button B has two outputs. Because button B, which is an input, has two drinks, or drink choices, which is an output. So, because there's two outputs for the one input, it's not going to be a function. So, let's look at using function notation to figure out a problem and solve for a solution. So, in number 3, we have f of 10. The letter outside of your parentheses is going to tell you what function to use. The number that's in the parentheses is going to tell you what you substitute for x. So in number 3 we have f of 10. So we're going to use the f equation and we're going to substitute 10 in for x. So everything else stays the same, so it now becomes 3 times 10 plus 5, and then we're just going to evaluate. So using order of operations, 3 times 10 is 30, plus 5 gets me 35. Number 4, we have g of negative 1. So we're going to use our g function, and we're going to substitute negative 1 in for x. So I'm going to rewrite the problem so it's now 11 minus parentheses negative 1. And I'm going to evaluate. So two minus signs make a plus. So this is really 11 plus 1, which is 12. Number 5, h of 4. So we're going to use our h equation, and we're going to put 4 in for x. So when I substitute that in, I get negative 5 times 4 minus 3. Negative 5 times 4 is negative 20, minus 3 gets me negative 23. Now, in 6 and 7, we have numbers outside of our parentheses. So what we're going to do with that is after we look at our function, we're going to multiply by whatever number is out front. So in the first equation, we have 2h of 0. So we're going to put 0 in for x in the h equation, but I'm going to put it in brackets. So negative 5 times 0 minus 3. This 2, that's my coefficient, is going to go out front times 2. So I'm going to evaluate the function, and then I'm going to multiply my answer by 2. So I have 2 parentheses 0 minus 3, 2 bracket 3. So now I can multiply, and I get negative 6. We're going to do the same thing in number 7, where it's negative 3 f of negative 4. So we're going to put negative 4 in for x. In my f equation, I'm going to put a negative 3 out front. So bracket 3 times negative 4 plus 5. I'm going to take this negative 3 and put it out front. So now I'm going to evaluate what's in the bracket first. So negative 3 times negative 12 plus 5. Negative 3 times negative 7 gets me 21. Let's look at some more problems with different functions. In the first problem, we have p of negative 2. So we're going to take our negative 2 value, and we're going to substitute it in for x in my p function. So when I substitute, I now have parentheses negative 2 squared plus 5. Negative 2 squared is just negative 2 times negative 2, so 4 plus 5, which gets us 9. In number 10, we have q of 5. So we're going to substitute 5 in for x in my q equation. So when I rewrite this, I get negative 14 plus 3 times 5 squared. So order of operations, I use my exponent first, negative 14 plus 3 times 25. Then I multiply, negative 14 plus 75. Negative 14 plus 75 gets us positive 61. In our last equation, we have to be careful again with that 2 out front. So we're going to substitute negative 4 in for x, but I'm going to put it in brackets. So bracket negative 4 squared plus 5. I'm going to bring that 2 and place it in front. So I now have 2 times negative 4 squared is 16 plus 5. 16 plus 5 is 21. So then I have 2 times 21 is 42.